Harrisburg, Virginia. Dr. Papanicolaou has academic experience at Washington State University, University of Iowa, where many of us got to know him, and also University of Tennessee. So he's had a distinguished career as a mentor, teacher, and research scholar. At the University of Tennessee, he served as the director of the Tennessee Water Resources Research Center, leading statewide efforts on water issues. When he was at Iowa, as a professor, he established the Clear Creek Observatory, one of 10 such sites in the United States. Most recently, he served as the senior advisor and engineer with the Northwest Hydraulics Consultants in Seattle, Washington, leading large-scale projects on watershed research and development. He has also partnered with industry to develop advanced sensors for flow and sediment movement, as well as scour erosion detection and the ability to transfer hydropedagogic knowledge and soil quality to originated paper. He has received $35 million of project funding, several federal and foundations. He has received several awards and distinctions for mentoring early career researchers, leading multidisciplinary, multi-institutional research, establishing hydrologic observatories and laboratories of national and international stature to study biotic and abiotic processes, publishing fundamental research on the role of scale in flux predictability, and promoting scholarship and visionary systems approaches, which will be probably a keyword here, systems approaches, to study interactions and feedbacks. He's a fine candidate to serve as director of our lab. He has a sincere interest in virtually everybody that he meets, certainly in our building, all for promoting good quality, high-level research. The title of Dr. Papanicolaou's presentation is Opportunities.
Well,
I got a different one.
Yeah.
Okay, take it from here.
I think, let's see, how we're doing with the sound here. Can everyone in Zoom hear me well? Okay, I guess people are muted. So a great pleasure. I see thumbs up. A great pleasure to be here. It took about 20 some years to be a speaker in the agronomy department at ISU. I've been, that's not a complaint. Actually, I feel very fortunate to have the opportunity here today. I have always interacted with several ISU members of the faculty and the ISU community over the years. Also with NLAE when I was in the various institutions. And I think really the great partnership that exists between ISU and the National Lab for Agriculture and the other ARS locations here on campus and beyond is exemplary. I think the opportunities are there. We had some recent efforts and proposals, and I'm looking forward actually to grow those opportunities in the near term, but also in the longer term. So thank you, Dan, for the introduction. I thought instead of starting with the NLE opportunities, I'll finish, that will be my ending point. I will talk a little bit about research that I have done. I've been here only 8 months, so I haven't been able to get my hands around doing real things, but so I'm borrowing a lot of the stuff from the past. And one of the things that I have been very much interested is connecting basically uplands, landscapes with rivers and looking into the challenges and future directions in that area. So one of the people that influenced me very much over at the beginning of the career was Hander Rouse. Hander Rouse happened to be the Iowa director, one of the directors of the Iowa Institute of Hydraulics Research at that time. I loved his fundamental understanding in fluid mechanics, and fluid mechanics can vary, air to basically, liquids, all kinds of things, water primarily. So another person who or another family that influenced me very much is the Leopold family. As you know very much, everybody knows the work of Aldo on this campus. And then his son, Luna, was a geomorphologist. Aldo was an ecologist from Wisconsin, native. And then his son, Luna, actually, I think they're natives from Iowa, but he was faculty in at the University of Wisconsin, a correction there. Luna was a faculty at Berkeley and a geomorphologist. So as you can see, ecology, geomorphology, those are kind of very much pivot points for my career. Over the years, I looked into in a variety of thematic areas, but one of the things is the connectivity, which is the center of my presentation here today. I'm going to give you just snapshots of what I have done, primarily in intensively managed landscapes. And that means agricultural landscapes, but beyond. Urbanized systems are falling into that category. And then I have looked into sediment transport and intermittency, and that's grain-to-grain interactions and the effects of near-bed turbines. And then hydraulic infrastructure and stream geomorphology. So when it comes to connectivity of the landscapes, this is a picture from Palouse, where you can see here a lot of the genesis of those reels. I have not seen parallel reels in real life other than in modeling exercises, where we assume reels are delivering material and runoff and nutrients, downslope. So I put that picture there. But one of the things that we are looking really as central hypothesis in the intensively managed landscapes is that IMLs have passed a tipping point, primarily resulting from human modification, and have gradually shifted from being a transformer with high nutrient, water, and sediment storage to being a transporter with low nutrient, water, and sediment storage. And I think the system is in disequilibrium, and I know someone may challenge me with that term, and maintained, so due to maintain to that disequilibrium stage due to the anthropogenic activities. And then the second factor there is the event dynamics that I believe are more important than the seasonal or annual averages. So you can see here the two boys pulling that rope and kind of, getting that sense of disequilibrium. And that disequilibrium has to do with a lot of the anthropogenic activities. You see the channelization there of streams of stream order here in the Midwest, primarily for farmers going there to gain more land and therefore channelizing those systems. And one of the challenges that we have there is obviously landscapes are heterogeneous, and that heterogeneity introduces a cascade of nonlinear processes for biota, soil, and water. And you can see here a couple of mechanisms. I'm trying to simplify things when it comes down to soil organic matter. You see, obviously, landscape, topography and characteristics, convex, concave, play an important role. We have downslope and lateral contributions. We have soil particles and aggregates. And we have the oriented roughness affecting the formation of those pathways that bring that concentrated flow towards the floodplain and then towards the channel. And we have, along with that, the M1 mechanism, which is basically mobilization of the finer organic material. We have the M2, that is the residue mobilization, deposition, and then actually incorporation within the soil column. We have the M3 mechanism, that's this respiration of non-complex organic carbon that is near the floodplain, where we have more soil moisture built up over time. And then we have and as the mobilization occurs, we have oxidation taking place. And then the last mechanism is obviously the formation of organic carbon mineral complex. And as we try to, when we try to model things, we try to sort of simplify some of those factors, starting with the topography. So you see there the overflow elements, those are increments assumed typically linearly. Now with the GIS incorporation, let's say into various models like GeoWeb, you can incorporate basically LiDAR information into those models. But then you can see the routing process going from one increment to another, and along with that, the particulate matter and residue. So if this is an example of what goes into those models, and you see the heavy parameterization that is built up in those models. This is the water erosion prediction project. I have to showcase ARS work from Purdue, West Lafayette, the soil erosion lab, where you see there the basic assumption in this equation is that time is not a factor, when in reality time, this G, capital G, is flux. But things are changing not only downslope in space, and we can write this equation in a 2D form, but also with time. And then you have obviously contributions. This is the interil area, the lateral contributions that you saw in my schematic earlier, and then the concentrated term here. These are flux terms. So we need to, as you see, the challenge is, this is the continuity equation. Some people call it the Exner equation. And we can write also, there are improvements over time. You can write the momentum equation. But one thing, which is basically the second Newton's law. But one thing that is very difficult is, and people who work with natural systems, ecosystems, realize is how you can address some of those site-specific parameters. And this is a challenge that is there, and we cannot ignore it. So along with modeling, we need detailed observations. And therefore, those observatories that Dan mentioned, the critical zone observatories, or the LTAER, or that's the ARS observatories, or the LTER, the NEON observatories, NSF funded, those can play, they address certain facets of this problem, but we can get some interesting measurements addressing some of these issues. Another issue is the term scaling up, and how we can preserve basically the non-linearities that we have at the smaller scale, and understanding the impact of those non-linearities such as roughness and residue cover, and the implications of those to the larger scale. So there is a lot of interesting work done in this area, and understanding scale-dependent thresholds, but also some of those emergent patterns of property. And the way to do that is you start with cause and effect relations, but then also using what everybody talking nowadays, data science. You can identify emergent patterns, and then you can go top down and be able to sort of improve predictability of rates. This is flux rates, and also threshold dynamics, how they change as you go from the plot to the large basin. And one thing that we are struggling now in ARS, but also the broader community, is really understanding time lags and understanding basically how long it takes to see the benefits of certain management, how that impact propagates downstream. And here what you see is this is, again, this equation that was written before in terms of X. Now it is written in terms of X and time. And then along with that, we have the bed elevation equation. And you see here that Sisabel parameter, and this is what we call the special lag coefficient. So the special lag coefficient is essentially an ensemble averaging of all of those parameters that we mentioned: roughness, cover, structure BMPs to the downstream fluxes. One way to get around to some of those assumptions and hypotheses that an Eulerian approach, a fixed coordinate system approach, provides is obviously to move with more of a Lagrangian system. And the new generation of models pushes along that direction. So what you see here is the incorporation of new, what means Lagrangian? You are following the point load. You are following, you have enough computational capacity to be able to follow individual particles, to be able to follow, you know, a cloud of nutrient mobilizing and diffusing downslope. So the virtual velocity concept is essentially serving that Lagrangian approach, and essentially accounts, when it comes to particulates, for resting time of the material, meaning material stores, deposits, rests for a while, and then mobilizes again with the next subsequent event. So I'm going to skip this. The third challenge is really understanding what's going on in what I call depot centers, and banks are important. They're critical interfaces in those delivery mechanisms. And I'm going to play this. You can see here with those cameras, we can see, you can see failure along those bank interfaces, and kind of understanding those you know, critical events. This is actually from the Iowa River, very close to the Iowa City, where farmers took hands on their own, you know, action on their own hands, and put old vehicles as a countermeasure to prevent further migration of the Iowa River. In that section in Johnson County, the Iowa River is meandering, and therefore kind of to mitigate that, sort of to prevent and control erosion, they put those old vehicles in there. But we can do better than that. Nowadays, with those photoelectronic erosion pins, someone can get, let's say, you know, continuous measurements of bank retreats and use that to calibrate and get budgets. This is work that was done actually, as you see, Iowa Water Center, getting budgets primarily focused on sediment and looking from where material soil is coming from, the provenance of material, and using an unmixing model, trying to isolate hot spots and hot moments in those water sets. And these models were verified then with field work. Then we couple this work with tracers, and we use beryllium-7, as you can see here, and we have followed the hydrograph in that system. And you can see here, upland is the gray, brownish, whatever it is, and green is the material derived within the channel. So you can get an idea when you do a sediment budget. We're using the short-lived beryllium-7 normalized with lead-210 to be able to get an idea about age of material found in a channel. The other topic I mentioned is intermittency. And intermittency basically is defined here is that variation around the mean, the average value, which is that horizontal dashed line. And when we try to predict how much soil erosion we got or how much flux of material is mobilized. Yesterday or 2 days ago, we had a presentation at NLE with John Kruger, where he was relating basically fluxes with friction velocity or the covariance there of the velocity. That's basically the stress. And that is that tau value. We know how all those models, well, name it, process-oriented models, relate flux to stress. And for whatever reason, there is a universal law that tau is function 1.5, 3/2. That has to do with the characteristics of the system. But when it comes to lower conditions, lower flow conditions, then that law breaks down. And a lot of that has to do with that kind of organization or self-organization of the system. And there is no better way to study this, but in a laboratory flume or a channel where you see here those colorful particles, marbles that you are used to simplify to replicate grain mobilization, where you see even when we simplify shape, we are dealing with spheres. Again, we see that grouping of those particles, those grains, and we call that phenomenon the clustering phenomenon, that in our applications here leads to the genesis of those aggregates. Except the mechanism for one of the mechanisms for the formation of the aggregates is actually from raindrop, and runoff, the collective action. Here is primarily concentrated flow. So I'm going to play loud. For whatever reason, the video doesn't play, but that's okay. So what we are doing, another thing, what is very interesting to, in the past is like in atmospheric flows, like flows over vegetation, the same thing, flow over a boulder here, which is a roughness element, flow over a building. You have those eddy structures, those vortices. So we have tried to develop what we call a vortex topology. Let's see if this will play. So as you see here, we have what we call that horseshoe vortex, because it looks like a horseshoe. And then on top of that, we have that arch vortex that primarily is from the top, setting off the top of that object. The same thing, that's when we're talking about flow over vegetation. The only thing is vegetation is bendable. Here we're dealing with rigid applications. So I'm going to stop here and then discuss how much time we've got, maybe 5 minutes. So
to save time for question and answers, we probably have
2 minutes.
10 minutes tops.
Okay, I'll be quick. So hopefully you can see that again. I want to talk a little bit about NLAE. NLAE is pretty much equivalent to me stakeholders. And ISU is one of our partners, but a stakeholder. So we built on ideas. I think our partnership, as I mentioned, is extremely strong. We work well with the Vice President of Research Office. And we are trying to continue and grow that strong relation. How that translates using our facilities and also using our some of our practical research in complement to your some of the fundamental research that you are doing. How that translates? It translates to joint efforts, writing, going after proposals where we can be partners with you, or you joining us in some of those efforts. I think it's a mutual way. And we respect that. But just the footprint of NLE is national and global, I may say. We have people in the lab, John Brugger and his team working in California as part of the GRAPEX program. We have people in the lab being very active with the long-term agriculture research observatories that ARS has established, and focusing really one asset that we're very big is this long-term data. And we're willing to share this data with our academic partners. This is a great opportunity to do a synthesis of data, to look, as I mentioned, into those emergent patterns. But then those data can help us with some of the new modeling efforts. And this is kind of the current state of those LTARs. They have been there for some time, for more than 10 years now. So we have enough data observations in different landscapes, different geographic locations, hydrologic regimes, soil types, that give us enough information, not only about cropping systems, but also about and management practices, but also some new technologies like precision ag that they're doing down in Texas and other locations. So another thing that this is very close, I mean, I have an interest, is in partnership with the Department of Energy, looking into the concept of circular economy, looking into small impoundments that there are in many of the small streams in parts of Iowa, but in other parts of the US. And looking into ways, like in Des Moines River, there are a lot of those spillways where you can put a hydrokinetic turbine. And I don't have the numbers on top of my head right now, how many greenhouses we can have for specialty crops. That sediment soil that is captured, which is fertile here, behind those dams can be utilized as a fertilizer. And also some of that water in other areas can be a source for irrigation. So right there, working with industry, we have been this is something that we're working on. And there are people on campus, actually, who have interest. They're looking into beaver dams and the opportunities that beaver dams can give us in that circular economy concept. Obviously, in partnership with various entities looking into carbon. There's a lot of discussion about carbon credits, and therefore having in more accurate way to sort of quantify how much carbon is in a farm field. This is quite important. The other thing that we do is outreach. We work with a broader community here in Ames and in other areas to sort of discuss ways of, as Dan mentioned, we view things as a system. So we have the environment, we have production, but we need to keep things in balance. And then we have all those exogenous factors, increased demand for food, climate. We need to sort of balance things in a way that the system is economically competitive, but at the same time, the broader community health is there, and that's economic, that can be ecosystem health. This morning, I met with a group of stakeholders, small producers, organic farmers, business people, associations. And one thing that was clearly, we talked about soil health, and I know that's a term that we need to define, and there are different definitions, but how important soil health is to community health, and how important, let's say, what we do in terms of management practices, how that is reflected to the overall human health, actually. So making those connections is very important as part of that system. So I think try to sort of combine with two presentations to be able to sort of connect what I have done personally in terms of research, and then some of the opportunities that lie ahead for all of us here to grow further. Thank you.
Well, we have a good amount of time for questions and discussion, both here in the room and those people online. Let's start with the room here. Anybody here have a question? Michael?
Thanos, thank you very much for coming across the parking lot to talk to us about NLAE. This is really important for us and to keep the communication between these two institutions going. We're really glad that you could come to talk to the soil science seminar. I wonder, does NLAE have a regular seminar series or a regular opportunity where we might come and talk about some of the things that we do to help make some of those connections?
Right. That's a great idea, Michael, as we do. And we have someone, actually, maybe they're listening right now, who is leading this seminar series. We do it on a monthly basis, but on and off. It's with people from, researchers within NLAE, because we're trying to learn what we do. We got a large group there as well, but also from other groups. I mean, we're going to have some joint seminars with the National Center of Soil Survey, Sky Wills, and others. And I know Sky is going to come here for a seminar. Then we are having other groups from other ARS locations. So yes, the answer is we need to do that. We can have some of you there. I think we need that polyphony of ideas, and we are having also our quarter meetings with the Vice President of Research Office. We meet, it's more high level, but I think, and some of those initiatives, therefore, like your VPR in the recent White House meeting that was on climate, mentioned there are kind of evolving kind of along those lines, that key interaction. So we'll look into this. Yeah.
Michael, what was your vision? Was it individual faculty members coming over presenting on their own research program, or broader based discussion with this department and Henley together?
Yes, yes, and yes.
Okay.
Yes, and yes, exactly. And I think because we got at least, 4 early career scientists that just joined, and that, they need to know what you guys are doing. And some of them are actually in Peoria this week for their orientation. And so we got some, new blood in there, and also you guys are evolving too. So it will be a nice opportunity. And I know this is a top department nationwide and globally. So I think keeping, that interaction, we need to take advantage in a good way. Yes, good point.
That's come up in discussion recently. Some of your the universities remote sites, some of the collaboration going on there, people within this department interacting with our people, and how can we promote that interaction further?
Mm-hmm.
Should be all types of things that we could talk about. Who would spearhead that discussion from this side? Your department head, or Michael, or
Could be, there are a variety of people who could, and we could tap. Sure.
Yeah. And we can do it organically too, but it will be good to some level of coordination. We can do that, yeah.
okay? Any further questions from inside the room here? Okay. All right, Laura, any questions online?
Yep, go ahead.
I asked them if they had a question
Oh, I
to
see.
unmute their mic, and I was gonna remind them with my voice, but that's when you got the feedback. So nothing has been, not see anybody raising their hand or typing in the chat. So we've got time to answer more questions from the room here.
Yeah.
I have one on the hydrologic side.
Mhm.
What would be the main? I mean, I think you showed pictures showing the real world impact of that work. One was stream bank erosion. Is there also some benefit to downstream deposition of sediment or movement of sediment downstream? Or could you talk about the real world implications of that work?
I think obviously controlling bank erosion is a significant factor. I think just focusing in Western Iowa, that's it's an excellent example, the Nishnabotna system, where we got significant mass erosion primarily because you got those steep gradient banks. So controlling bank erosion there, the other good thing is phosphorus, particulate phosphorus, controlling. Now, in terms of benefits of material being deposited, you do have those depot centers. We call those in geomorphology sediment bars. And those are very rich actually in organic material. And you want to encourage those sediment bars forming. And if you can sort of manipulate them in a way that they can be stationary, I will not say the term at equilibrium, but they are there, then the benefits are significant, not only from, the stream itself, but the benefits are there also for aquatic life, because they use that as refuge, as habitat to, and because that sediment is organic, you have insects, you have the whole chain of food for fish and other, aquatic life. So that's another benefit of that.
I mean, that's one example of your interest in systems, looking at how things weave together. Do you feel that there's not enough of that vision elsewhere in the scientific world? Or is it just something that you're innately interested in?
I think in this, there have been some tremendous ideas. Probably that systems concept, actually the story is it started from the industrial world, where things are viewed as, systems. You have, you compartmentalize, you break things into small compartments. And so it started from there. But then due to the challenges that we have in, natural ecosystems where we need to have a variety of data, that never, it stayed more in the conceptual level than, more quantitative. So for example, right now, we are using one of those systems platforms from industrial engineering. Kasab is using Vensim. That's a software platform that allows him to look into those biodirectional back and forth interactions, inputs and outputs, stocks, and how those stocks change in various quantities based on different factors and different interactions, endogenous and exogenous. But he was, he's looking into integrated crop livestock systems. And so he's looking into nutrient cycling, he's looking into, how much, for example, we're looking into scenarios, how much cattle we need to, or how much, cattle in this particular case, and how much pasture land we need to have in Iowa in order to see so much reduction in nutrients. I know that's not maybe realistic, but this type of system approaches are allowing us with more quantitative means to look into some of those ifs and hypothetical scenarios.
You raise your hand so we know who you are.
Hello, Thanos.
Kasab? Yep.
Hi, my name is
Hi.
Bob. My name is Bob Horton. I'm on
Yes.
the faculty here at ISU. Hi.
I know.
Thanks. Thank you. Thanks for your seminar today and giving us,
Sure.
briefing us on your own personal interests and also telling us something about NLAE interests. And I wanted to ask a question. I know in the past, NLAE sometimes organized their scientists around, certain objectives or certain areas of interest. I also know that you have a whole bunch of new early career scientists that are there with you now. But I'm just curious if you have any themes or any groupings or any topics that you're organized around right now. Are there any things like soil health or, soil erosion, or are there any kind of themes that your objectives, overall objectives that NLAE is trying to address right now?
Right. Well, certainly we do have a lot of specific objectives as part of our projects, our base funds. Actually, we're happy to actually develop pagers for each of those projects. So before answering the specifics about the objectives, your Associate Dean for Research and I, we have been in communication, and I provided about 7 to 10 names from our lab, and she was going to organize also 7 to 10 names from the college here, people that they are working on soil, water, air, and then also on management. This is broad areas. And we made the first step. I provided those names. And then I think it was more a time constraint. We're super busy getting people, new people on board with searches and etc. and other things. And then the timing for Carolyn also was not there. We're unable to get the appropriate sort of time. But yes, Bob, we made the first step, which is there are some names of scientists from NLE that they've given to me their names, and they're interested to have a first meeting and identify some of those thematic areas. Clearly, we're working on soil health, as you know very well. Doug Carlin, Cindy Cambardella, Dan, and others, Dana. I don't want to leave anyone out from that topic that have contributed. Clearly, smart management practices is a topic. Looking into nitrous oxide emissions and gases, point source gases and non-point source is another area. But one of the goals of that meeting that we wanted to put together is to put those mini talks that can identify with laser beam accuracy some of the topics that you are referring to. So we will be able to sort of come up with then working groups that can address in a more organized way some of those bigger initiatives out there. So instead of responding in an opportunistic manner, kind of having more of an organized way of addressing some of those initiatives where ARS and ISU partnership is beneficial, we thought that will be very important. So yes, we had this idea there. I think right now is the David Peters unit that is doing that with your colleagues, with CALS, but I think hopefully in September, we'll be able, that is kind of a tentative timetable, we'll be able to organize those thematic areas. And that has to do a lot also that I'm new here and trying to get a lot of other urgent things off my table, off my desk, yes.
Well, thank you so much.
Hey, Bob, do you see any areas that would complement what your soil science group is doing here? I mean, what are your areas of strength? And should we compliment you on that?
Yeah, I think in a lot of areas, many of the things that were mentioned today on erosion and soil health and all the things that Thanos just said, I think there are people here in the faculty in the soil science group here, plus the broader faculty at Iowa State that have interest in many of those topics. And I'm a little bit gray in the beard, and I'm not sure how modern my skill set is, but I'd be happy and pleased to meet with any of the scientists at NLAE for discussions. So thank you so much for coming today.
Thank you. Offer is taken. Yeah, I think that's a good suggestion. So we'll look into that. Yep.
Okay, we're a little bit past the hour and we can stop now. Are there any really urgent questions anybody needs to raise right now? Otherwise,
you can email me if there are any other questions there. But yeah, this is a great campus, great opportunities here. Bob mentioned, I'm very much familiar of your work down at the poro scale. So a lot of high quality of work in soil physics, agronomy, management practices, modeling opportunities. I think you guys are leading some of the efforts with APSIM. here in the country. So a lot of good stuff. I think I recognize a lot of the names.
Okay,
Yep.
very nice, very nice. Okay, well, once again, thank you, Dr. Papanicolaou.
Thank you.